Hi guys, this is your Chapter 8 review. Good luck on your test, and feel free to fast forward to any of the parts that you need help with. Alright guys, when we look at this one, we get confused sometimes on our test because we're not sure what to do. We see those parentheses, we see the addition or subtraction sign in between the parentheses, and we're not sure if this is a multiplication problem or an addition and subtraction problem. So the very first question that I want to answer with you is what is the function we're seeing? Are we seeing a multiplication problem or are we seeing addition and subtraction problems? And the answer to that is we are seeing addition and subtraction problems. We are seeing addition in the first one, we're seeing subtraction in the second one. We are not seeing multiplication or division. Now the multiplication and division that you think is, now that we know we're working with an addition or a subtraction problem, it's time to ask ourselves the next set of questions. The two questions that I come up with in my mind are, what are like terms, since my job is just to combine them in an addition or subtraction problem. And the other one would be, in the second problem, why do I have to distribute that negative? So let's deal with the first question first, is what are like terms? As you can see on the bottom in the green there, I have the question, what are like terms, and I have an answer. Same variable raised to the same power. So in the very first question I see there, or very first expression, I can see that my highest exponent is a negative x to the third. I'm going to look for any other x to the thirds, and I'm going to combine them. I can only combine them with another x to the third. So do I have any other x to the thirds in that first problem? I don't. So I'm just going to bring it down. My job is simply just to rewrite it because that is the total value of x to the third for this problem. So I'm going to bring down a negative x to the third. I'm going to continue on. I'm going to look for my next highest value. I can see I have a 2x squared. I'm going to look for another x squared in the problem, and I don't see another x squared, so I'm simply going to bring that down. Now, don't forget to bring down your addition or subtraction sign that goes along with each term. And as you can see, this one's a positive 2x squared. Now, I'm going to continue on with the next highest power I see. The next highest power I see is I see a negative x to the first, and on this side I see a positive x to the first. Now a negative x to the first, a positive x to the first, once I write those down, and I will for the sake of showing you, you're going to see that these two terms will cancel out once I simplify. Finally, I'm going to look at my constants. My last two things are my constants. I have a plus 8 on one side and a negative 3 on the other side. Guys, remember my rule. Whenever I have two numbers with opposite signs, I'm going to use those like this. Here we go. It's 8 minus 3. Treat it like a subtraction problem. The answer is 5. And I'm going to keep the sign of the bigger number. And in this case, the bigger sign, the bigger number is here in my plus 8. Here is my bigger number. That is a plus 8, so that means my answer is going to be a plus 5 in the end, not a minus 5. So at this point, I have either combined like terms, or at least I've written it so I can combine like terms in this last step. And my last and final step here is simply going to be to just rewrite it into its final form. So combining like terms, I have negative x to the third plus 2x squared. My negative x and positive x will cancel out to 0, so I don't write anything at all. And then finally, my plus 5. And that is the first problem written in simplest form. So let's answer that second question now. Why do we distribute the negative in this second problem? So in the second problem, I see a negative in between the two trinomials, and the only reason that I'm going to distribute a negative, and what I mean by distribute a negative, I'm going to multiply each term in this trinomial by a negative 1. And I know earlier we said that this is an addition and subtraction problem, and it is, but I would prefer to work with this as if it was an addition problem. Addition is just simply easier for me to work with than subtraction when I'm working with trinomials. So the very first step I'm going to do is I'm going to distribute this negative 1 to all the terms and rewrite everything. So when I do that, let me just go ahead and bring everything down. So this 4h to the third in the first trinomial, I simply will bring down and rewrite it, 4h to the third. And plus 3h comes down as well because nothing changes in this first trinomial. Now in the second trinomial, I'm going to, so as I distribute this -1, I'm going to look at -1 times -5h squared, and I now have a positive 5h squared. And I'll now distribute that -1 to the 6h, and I now have a -6h. And I'll distribute that -1 to the -2, and I now have a positive 2. I'm now in a position where I can combine all like terms. And let me just fix up that 2 there. Okay, there we go. And let me fix up that addition sign. Let me try that again. All right, so like I said, that step right there was to distribute my -1 to all the terms in the second trinomial. And the reason I did it is because I simply like to work with addition problems rather than subtraction problems. And from here on out, it's the same as the first problem we did, whereas we're going to combine like terms. We're going to look for everything with the same variable raised to the same power. So the 4h to the third is my highest power, and I'm going to rewrite that because there is nothing else raised to the third power. Let's look for h to the second, and I can see I have one and only one, 5h to the second, and it's a plus 5h to the second. We're going to look for all the h to the firsts, and I can see I have a 3h to the first and a -6h to the third. Remember what I told you last time? Whenever we have two numbers with different signs, we treat them like a subtraction problem. So essentially this is 6 minus 3, and we're going to keep the sign of the bigger number, which is a -6. So 6 minus 3 is 3, and it's a -3 because the bigger sign was negative. So we have a -3h, and our last job to do is to combine our constants, and I see I have a +1 and a +2, so those two will combine to a +3. Now I'm going to look across my new expression and see if I have anything that can still be combined or simplified, and I can't because all of my terms are combined with like terms. I have a 4h to the third plus a 5h to the second minus 3h plus 3. So this is in simplest form. I'm going to go ahead and box that so I can show you that we're all done this one right here. All right, guys, in this one, we're going to take a quick minute just to review FOIL. And when we do FOIL, what we do is first, outside, inside, last. As you can see from the picture on the left-hand side, FOIL is just an acronym, and it reminds us what steps to multiply these two binomials. So your first two terms are x and x, and there we go. Your first two terms are x and x, and what we're going to do with these two terms right here is we are going to multiply them. When we multiply variables, we add the exponent. So this becomes x squared. Our next two terms we're going to multiply are our outside terms, and our outside terms are the x and the -20. When you multiply these two, it becomes a -20x. My inside terms are +3 and x, and when we multiply these, we get a +3x. And my last terms are 3 and -20. A 3 and a -20 will multiply to a -60. And now all we're left to do is we have to combine like terms. When we combine like terms, we're going to look at these two terms right here in the middle. Now we talked about on the last page that like terms means the same variable raised to the same power. We can see that these are x to the firsts, and then we need to combine these two to have this in simplest form. So that's what we're going to do. We are going to combine these two. So when I do that, I'll bring down my x squared and a -20 and a +3. Remember, what do you do when you have two numbers with opposite signs? You treat them like a subtraction problem. So 20 minus 3 is 17. Don't forget your variable, 17x. And the sign will stick. The sign we're going to use is a sign of a larger number, which was a -20. So now it becomes a -17. And finally, we're going to bring down that constant. That constant is a -60. At this point, we have simplified this as far as we could, so there's nothing else to do. Our final answer is x squared minus 17x minus 60. All right, on this page, I'm just going to do number 2. And the reason that I'm choosing to do number 2 is because sometimes when you see the binomial raised to the second power, you're not sure what to do from here. So I'm just doing this one just to remind you, if you see a binomial raised to the second power, what they want you to do is they want you to rewrite it to x minus 4 times x minus 4. And from this point, you're going to FOIL. You're going to go first, outside, inside, last. And when I do that, x times x gives me x squared. My outside terms give me negative 4x. My inside terms give me negative 4x as well. And my last terms give me a positive 16. Last thing I have to do is combine my like terms, and my like terms are the ones that have the same variable raised to the same power. And my like terms here are negative 4x and negative 4x. When I have two numbers with the same sign, I add those two numbers and I keep the sign. So when I simplify this, this becomes x squared minus 8x plus 16. Final answer. This problem asks us to find the perimeter and area of the given rectangle. Let's take care of the perimeter first. When we're finding the perimeter of a rectangle, what that means is we're going to add up all the sides. Before we start this, let's go ahead and finish labeling all of our sides. So let's go ahead and label this side x squared plus 4x minus 1, and this side x plus 3. Now what we're going to do is we're going to find like terms and we're going to combine them. The first set of like terms I see are x squared and x squared, and since we're adding, we have 2x squared. If you notice, much different than multiplication, what we do with exponents when we're adding and subtractions is we leave them alone. We will add x squared, and that will give us 2x squared. I'm going to look for my next highest exponent, and what I see is I have x to the first on all four sides actually. I have 4x up top, 4x down low, and on both of my sides I have an x and an x. So let's go ahead and add those up. When I add those up, I have 4x plus 4x gives me 8x, plus one more x is 9x, and my final one gives me 10x. So now I have 2x squared plus 10x. Before I'm finished, I have to add up my constants. When I look at my constants all around my shape, doesn't matter where I start, I can see that I have a plus 3 and a plus 3, which gives me plus 6. And then I have a negative 1 and a negative 1. So my total now is 6 minus 2, which is 4. So my total value of my constants is plus 4. Now at this point, there are no like terms to combine, and that's how I know I'm done finding the perimeter of this shape. Now the thing you have to make sure you include is you have to include some sort of measurement value. So this is going to be 2x squared plus 10x plus 4 units. And that is the last part of this answer. Okay, we're going to use the same rectangle to find the area. So when we do that, the very first thing we're going to do is we're going to write down the formula for area. And area equals length times width. Area equals length times width. Now, the first thing I want to do is I want to set this problem up horizontally just so I can have a better view of it. So here's x plus 3. And we're going to multiply that by x squared plus 4x minus 1. In order to multiply a binomial times a trinomial, what we're going to do is we're going to rewrite the problem, and we're going to multiply everything by the first term of the binomial, and then everything by the second term of the binomial. And here's what that looks like. X times the quantity of x squared plus 4x minus 1. And then it's going to be 3 times the quantity of x squared plus 4x minus 1. And now that I have that all set up, what I'm going to do is go ahead and distribute the x through the first trinomial, and then I'll distribute the 3 times the trinomial, and then I'll combine all like terms using addition and subtraction. So x times x squared becomes x to the third. X times 4x becomes plus 4x squared. X times a negative 1 is a negative x. And let's just continue on with that. We got 3 times x squared becomes a positive 3x squared. 3 times 4x is going to be a positive 12x. 3 times negative 1 is a negative 3. All right. So what we're going to do here in our last step is we're going to combine like terms. When we combine like terms, what we want to do is we want to look and we want to find like terms, which means the same variable raised to the same power. The highest variable I see, well, the highest variable and power I see is x to the third, but I see no other x to the thirds in the whole problem, so I'm going to bring down that x to the third. Now I'm going to look for the next highest variable in power, which is an x to the second. I have a 4x to the second plus a 3x to the second. When I combine those two, I'm going to have a plus 7x to the second. Next, I'm looking for the next highest variable in power, and I see a negative x and a positive 12x. Remember, guys, when I see two numbers with opposite signs, I treat them like a subtraction problem. So essentially, that is 12 minus 1, which is 11x, and I'm going to keep the sign of the larger, and with that, the larger value here is 12, so it's a positive 11x. Finally, I'm going to look for my constants. I see, when I look across this problem here, I see a negative 3 is my only constant. So I'm going to just bring that down. There's nothing combine the two. Now, the last thing you want to do is just double check, make sure there is nothing that you can still further simplify. Before this can be finished, we have to make sure that we assign a unit of measurement to it. So since we're finding the area, the final unit of measurement we're going to assign to it is we're going to assign units squared. So our final answer will be x to the third plus 7x squared plus 11x minus 3 units squared. Final answer. Find the volume of the given cube. The formula for volume is V equals length times width times height. So it's a multiplication problem. So I guess the thing that might be confusing for someone is how do I multiply 3 different monomials or binomials or polynomials? How do I do this? So when I look at this, I'm simply going to write them horizontally, and I'll decide from there. I always start with my monomial, just a personal preference, and then I'm going to write my 2 binomials side by side. So I have x times the quantity of x plus 3 times the quantity of 3x minus 1. Now, when I have it set up like this, I simply decide, do I want to FOIL the 2 binomials first? Do I want to distribute the monomial through the first binomial and then FOIL both new binomials? You could do that. It really doesn't matter, but we'll just start somewhere. So here's where I'm going to start for no particular reason. I'm going to start by multiplying this monomial and distributing it through this binomial. So x and x are going to multiply to give me x squared. This is going to give me 3x. So now I have a new value for this, and I'm going to put that in parentheses, set up right next to my other binomial, 3x minus 1. And now what I'm going to do is I'm going to FOIL. I'm going to FOIL x squared plus 3x times the quantity of 3x minus 1. First terms are x squared and 3x, so it's going to be 3x to the third. My outside terms are x squared and negative 1, so it becomes a negative x squared. My inside terms are 3x and 3x, which are going to give me a positive 9x squared. And my last terms are 3x and negative 1. It's going to give me a negative 3x. So when I do this, just like in every other problem we've done, once you're done multiplying, you're going to simplify by combining like terms. The like terms in this problem are the x to the second powers. I can see that I have 2, and they're going to simplify with each other, but let's just start from left to right. So from left to right, I have 3x to the third, which is in simplest form because there is nothing else to simplify that with. Now let's combine these two. I have a 9 minus 1, because remember, when I have 2 numbers of opposite signs, I treat them like a subtraction problem. 9 minus 1 is 8. Bring down my exponent and variable. And my bigger sign is a plus, so it's going to be actually a plus 8 squared. And then finally bring down my last term, which is a negative 3x. This cannot be simplified any further because everything that could be has been combined already. So my final answer on this one is 3x to the third plus 8x squared minus 3x. Now I left some extra room in my answer because I know I'm not done until I assign some unit of measurement. Now since I am asking for volume, our answer is going to be units cubed. This problem asks us to find the missing side if the perimeter of the triangle is 8x plus 20. They give us the answer. When we add up all three sides, what we get is 8x plus 20. So what we're going to do is look at like terms, see what we have, and see how many we have to get to. So in the first thing we're going to look at is the 2x and the 3x. So I have 5x already. I already have 5x. I need to get to 8x, so that's pretty easy. I'm just going to make 8 minus 5, and when I have 3x. That was taken care of. Now let's look at our constants. When I look at my constants, what I notice is I have a negative 10 and a negative 6. So what that gives me is a negative 16. So what number do I need? If I need to get to a positive 20 in the end, what number must I have on my other side? In order to get to a positive 20 in the end, I must have a positive 36. So now I just figured out the value of my missing side. In order to get to 8x, and I already have 5x, I need 3 more x's. In order to get to a positive 20, if I have a negative 16, I need to add 36. So this is how I found the value of my missing side. All right, on this slide it asks us to factor the given polynomial. Now there's 4 different examples because each of these examples require a little bit something different in order to factor them. But one of the biggest mistakes I see when we're talking about factoring is knowing your signs and knowing when you factor what your signs are going to be. Will your signs be different? Will they be the same? If they are the same, will they both be positive? Will they both be negative? That's kind of where I see the most mistakes. So let's just try and touch on that real quick, and we'll just kind of use this as an opportunity to review. As soon as I see this, I'm going to look at the second sign in a trinomial. In a binomial, I look at the only sign. Now, when I see the second sign in a trinomial and I see that it's a negative, I know that that means my signs are going to be different when I factor. When I see a second sign that is positive, I know my signs will be the same. The next question actually, if your signs are going to be the same, is will they be both positive signs or will they both be negative signs? In order to figure that out, you got to look at the first sign. And in this one, if I were to factor this one, both of my signs would be positives because my first term is a positive. Going back to the first and second polynomials, when I'm factoring those, here's what I got to know. When I look at the first one at number 1, the greatest value that I see here in front of my leading coefficient, I should say. My leading coefficient is a 1. And since my leading coefficient is a 1, I know that my signs are going to look just like this. I can put my brackets up here in my parentheses. I can assign a plus here and a minus here immediately. Now the rule is a little bit different when you have a value here, which is greater than 1. And since a number 2, my leading coefficient happens to be a 2, I don't know in the end where my negative and positive values are going to be until I start plugging things in. So I'm going to have to wait until the end, but I can definitely tell you that 1 will be positive and 1 will be negative. Now in number 3, what we have is the difference of 2 squares. So what that means is every term in this binomial is a perfect square. 4 is a perfect square, x squared is a perfect square, and 81 is a perfect square. So what we have to do is we can just go ahead and write our parentheses down. And when I write my parentheses down, I know because it's a difference of 2 squares that I can put a plus in the first binomial and a minus in the second. And it really doesn't matter because a negative and a positive will make a negative in the end no matter how you order them. So like we said in the previous slide, as soon as I look at my second sign right here and I see that it's negative, I know that both of my signs in my factored binomial will be opposites. I went ahead and put in a g to factor out g squared. I put in a plus and a minus, and now I'm just going to find which factor of 14 I'm going to use, and I'm trying to get as close as I can to a negative 5 in the end. So my two factors are 14, which I'll put over here just so you can see them. I always put the lower number first, 1 and 14, and 2 and 7. So when I subtract one of these sets of factors, which one gets me to -5? 1 and 14 or 2 and 7? Obviously the answers are 2 and 7, and I want my answer to be a negative in the end. So I want to make sure that my bigger factor, which is a 7, goes with my negative symbol. So here's my negative symbol, so I'm going to put my 7 here, I'm going to put my 2 over here, and then I know, once I check it by using FOIL, that my original answer will come back out to the trinomial, and I'll know that I've factored this thing correctly. So for the sake of just showing you how to do it, I'll go ahead and I will FOIL this. G times G gives me G squared, and my outside terms give me -7G. My inside terms give me a plus 2G, and my last terms give me a -14. Combine my like terms, which are right here on the inside, that gives me a final answer of G squared minus 5G minus 14. And as you can tell, my final answer right here matches my original trinomial, so I know I have it right. Okay, let's factor number 2. When we factor number 2, let's take notice that the leading coefficient is not 1. The fact that it's not 1 will change how we do things slightly. But what it won't change is our signs. When I look at the second sign in our trinomial, it's a negative. And as we talked about earlier, when I have a negative in my second term in a trinomial, I know that both my signs when factoring are going to be opposites. I just don't know where to put them just yet. So we're going to wait off on that. We're going to hold off on that. But let's start off by factoring something quite easy, which is the 2n squared. Since 2 is a prime number, the only factors of 2 are 1 and 2. So it's really easy just to do 2n in your first binomial and n in our second binomial. And the next thing I'm going to do, just to help me see things, to visualize things, is draw these loops. These loops help me visualize the next part of the process. The next part of the process is seeing how can I get close to 3n. And the way I can get close to 3n is by taking my two factors of 2 and just assigning them. I can assign 2 times 2 to get me 4n. And that would put my 1 here, and that would give me 1n. Now remember, I'm trying to get to a positive 3n as my final middle term. And the way that I would do that is I would assign these signs. My sign should be a positive 2 here and a negative 1 here. And why is that? Why should that be how they're ordered? Because what that does, it gives me a positive 4n and a negative 1. And as you know, 4 minus 1 is 3. So in the end, I know I have 3n, which is my middle term, a positive 3n, which is my middle term, and that's how I know that I factored that correctly. Okay, the next one we're going to do is number 3. And number 3, what I'm looking at is the difference of two squares. And what we can do is we can factor a binomial only when it's the difference of two squares. And what that means is every term in this binomial is a perfect square. 4 is a perfect square, h squared is a perfect square, 81 is a perfect squared. Now, what this means is we can factor this, and we can go ahead and assign our signs pretty easily. Since it's a negative 81, I know the only way to get that is using a positive and a negative number to get there. The perfect square of 4 is 2. The perfect square of x squared is x and x. And the perfect square of 81 is 9 and 9. This is called the difference of two squares because every term in the binomial is a perfect square. And if I wanted to FOIL this, I could get 2x times 2x, and that would be 4x squared. I could do my outside terms, which is a negative 18x. My inside terms, which is a positive 18x. And my last terms, which make a negative 81. And what this does is these two terms in here in the middle will always cancel out when you have the difference of two squares. And that's going to leave you with your final answer, which is what you started with, 4x squared minus 81. Final answer. All right, our last one is finding the area of the shaded region. Now the trick of this one is that we don't need the total area, so we're going to subtract out that middle portion. So what we're going to do is we are going to rewrite this problem, and we're going to write our outside portion first with x plus 2 times the quantity of 2x plus 4. And we're going to subtract out that middle portion just like this. All right, now we're going to go left to right, and we're going to simplify using multiplication. And when we do that, I'm going to FOIL this for these first two binomials first. So x times 2x becomes 2x to the second. My outside terms give me plus 4x. My inside terms give me plus 4x. And my last terms give me plus 8. Now I'm going to distribute this negative x through the binomial. So negative x times x is a negative x squared. And negative x times 1 is a negative x. At this point, it's time to combine like terms. When we're combining like terms, we're looking for things, or we're looking for variables that are raised to the same power. Now, there's so much going on here that sometimes it's easier to use something to visually group them for you. So what I'm going to do here is I'm going to take all of my x squareds, which are the largest power I see. I'm going to put a box around them just to make sure that I don't miss any. Just helps me visually. So 2x squared minus x squared gives me x squared. Let's find something else now that we can combine. I'm looking for the next highest variable raised to the same power. And what I can see here is I got 4x and 4x, but I also don't want to miss this down here. I have a negative x. So I have 8x minus x gives me a positive 7x. The next thing I'm going to look for are my constants. The only thing that I haven't done are my constants. When I look for that, I'm looking for this 8 right here. I'm just going to bring it down because there's nothing to combine that 8 with. And my final answer for the area of the shaded region is right here. It's x squared plus 7x plus 8. Now because we're finding the area, we have to make sure that we assign it a unit of measurement. So we have to be sure not to forget the words units squared.